A 2-meter wide rectangular channel has a specific energy of 1.80 meters when it carries a discharge of 5.20 meter cube per second. Calculate the alternate depths and corresponding Froude numbers. Specific energy is represented by this equation. E is equal to y plus v square by 2g. Y is the depth, v is the velocity, and g is the acceleration due to gravity. This is the specific energy diagram. As you can see, there are two depths, subcritical depth and supercritical depth. They are called alternate depths. They have the same specific energy. Any particular discharge Q can be passed in a given channel at two depths and still maintain same specific energy. So this is a rectangular channel carrying discharge of 5.20 meter cube per second. So it will have two depths. Okay, it can have two depths. One will be the subcritical depth uh, and the other will be the supercritical depth. The supercritical depth it will have higher velocity, and when this channel uh, carries water at subcritical depth, it will have lower velocity. Okay, now let us calculate these alternate depths. Now, E is equal to y plus v square by 2g. Okay, now A is equal to width into depth, b into y. So we can write this equation in this form. E is equal to y plus q square by 2g into b square into y square. Okay. We want to calculate alternate depths y1 and y2. So let us first calculate the alternate depths. Now, E specific energy is given, it is 1.8 meters. Y1 and Y2 are yet to be calculated. Okay, I've just guessed these values to come to the optimum solution. Q discharge is 5.2 meter cube per second. The width of the channel is 2 meters and acceleration due to gravity is 9.8 meter per second square. Now let us calculate the alternate depths. Okay, so I have typed this equation. E is equal to y plus q square upon 2 into g b square into y square. Okay, now I will use goal seek data what if analysis goal seek. Now the value of E is 1.8 meters. Okay, so set the value of this cell to 1.8 meters. Okay, by changing this cell. Okay, so it will have two solutions. That's why I've written y1 and y2. First we will find y1. Okay, so y1. Okay, by changing y1, I want to obtain this value 1.8. So it has given me a solution 1.677 meters. Okay, now let us obtain y2. Okay, so this is the subcritical depth. Okay, we'll talk about it later. Let us first calculate y2. Y2 is equal to, okay, now goal seek. Set this cell to value of 1.8 by changing the value of this cell y2. So 0.519. Okay. So we have obtained two values y1 and y2. Okay. These are the alternate depths 1.677 and 0.519. Also calculate the corresponding Froude numbers. Now Froude number for rectangular channel is represented by this equation. F is equal to V by root G Y, which is equal to Q by A root Gy, because Q is equal to A into V. Now F1, I've already typed the equation. So V, instead of V, we'll be using this equation, Q by A into root Gy. Okay, so value of Q 5.2 divided by A, which is 1.677 into B, which is 2 meters, into square root of G into Y, 9.8 into 1.677. So we'll get the corresponding Froude number 0.3820. Okay, since its value is less than 1, it is subcritical. Okay, and similarly value of Froude number F2 corresponding to the supercritical depth is 2.21 using the same equation, but in this equation we used the value of y2. Okay, so these are the Froude numbers and these are the alternate depths. Okay, now when the channel carries discharge at 1.677 meters of depth, what will be the velocity? We can calculate V1 is equal to discharge by V is equal to Q A, yes, A, which is equal to B into Y1. Okay, so 1.55 meters per second. Okay, and this will have higher velocity. V2 is equal to Q by A, Q divided by A is B into Y, B into Y2. Okay, so 5.01 meters per second. So a 2-meter wide rectangular channel having 1.80 meters of specific energy, when it carries a discharge of 5.20 meter cube per second, will have two depths, alternate depths 1.677 and 0.519, and these are the corresponding Froude numbers. Okay, 1.67 and 0.519. So one value 1.67. This is the subcritical depth, and the supercritical depth is 0.519, having higher velocity. Okay, velocity of 5.01 meter per second.